Imam Taha, I think you can.
Okay. Yeah, I'm waiting for the sign.
Oh, okay. So he's going.
Yeah. Because once they put it on Facebook and YouTube channel, it appears here to me.
Okay. I'm learning from you guys.
Yeah.
You're all very high tech.
I've been learning this for exactly 1 year now. All right. Bismillahir Rahmanir Rahim. In the name of Allah, the most gracious, the most merciful. We start our session tonight by praising Almighty Allah and sending our peace and prayers to our beloved Prophet Muhammad sallallahu alaihi wasallam, his family, his companions, and all his followers. May Allah subhanahu wa ta'ala bless this session, bless our time. My dear brothers and sisters, Assalamu alaikum wa rahmatullahi wa barakatuh, and peace be with you all. Tonight, as we have announced, we are having a special session with experts, and this session is on the facts of the vaccine of COVID-19. Why we are having this session? Because not only our community, basically the largest society, people from all other communities, they need a lot of accurate information about the vaccine. Now we are in the middle of this vaccine campaign here in San Diego County, and we have seen some questions raised by a lot of community members. That's why we have preferred to have this session, inviting two great professors and experts from UCSD, Dr. Wael Ad-Dulaimi and Dr. Robert Cooley. So I welcome both of them, and I would like to start by introducing our first speaker, Dr. Wael Ad-Dulaimi. People from our community know him very well. He's very well known, very active member of our community. But just in case, if you only know him going in and out and giving some lectures from time to another, let me tell you that Dr. Wael Ad-Dulaimi is originally from Iraq. He finished his medical degree and postgraduate diploma from his native Iraq, and a PhD. He is a PhD epidemiology from New Zealand, and he was at Harvard School of Public Health and the World Health Organization before joining UCSD in 2004. He is a professor of public health at UCSD and was division chief of global health, and currently he is associate director of the Institute for Public Health. Thank you so much, Dr. Wael. Thank you so much, Dr. Robert. And with no further ado, Dr. Wael, you have the mic.
Thank you, Imam Taha, and thank you everyone for attending this session. I will briefly give some background about the topic and then introduce our guest, Dr. Robert Cooley, a colleague and a well-esteemed distinguished professor at UCSD. And he will kind of focus most of our talk today about the vaccine. So I have a few slides that I want to share, and let me see if I can. I think I have the ability to share. And it's kind of interesting. When I was putting some of these slides, I noticed the first presentation I did, a community presentation, was actually March 16th, exactly 1 year minus 3 days. So it is unbelievable how 1 year has gone, and we are now still struggling with this pandemic. So the this is a kind of a picture of the virus, and believe it or not, I'm using some of the same slides I used early on in a year ago, and the death numbers are increasing. These are some of the slides from the previous epidemics. SARS, there were about 700 people who died. Ebola, about 28,000. And the swine flu, about 150,000 to 575,000. And the what's called the Hong Kong flu, it was called because it started there. There was about 1 million deaths. And the 1918 flu, there were about 50 million people who have died. And so this is the pandemic that has happened, and the death has increased. Just in the US, we are close to 500,000, which is a huge number. And this is a kind of the main transmission mode. Again, these are the same slides that we started, that I put together a year ago, but it's really still valid that the main transmission is through aerosol. But now we're learning it's not just sneezing. If somebody is singing or talking or being heavy breathing or anything of that sort, just talking can have these minor aerosols, which are smaller than the droplets, that can be transmitted. In a normal kind of sneeze, there has been found about 100,000 bacteria, about 200 million viruses. They can travel up to 8 feet and very fast, also 100 miles per hour. And so this is how transmission is happening, in addition to by touch, and that the virus can survive on places that get contaminated and then gets transmitted to others. And the main damage was initially thought to be in the lung, but now it is affecting every system. It affects the renal system, causes renal failure. It affects the gastrointestinal system, causes diarrhea. It has been related to higher morbidity from infarction and embolism, and even brain damage or nervous system impact. So every system is being affected by this virus. Again, what we knew before is still a little bit valid, where we have about a 2 to 14 days period of asymptomatic transmission, where somebody is carrying the virus but without no symptoms, and that's the main problem, with an average of 5 days between getting infected and then getting the symptoms. So that period is the problem, where other infectious diseases, it's a short period where immediately somebody gets exposed, gets the symptoms, while this one is a little bit longer. So during that period, they are transmitting the disease and not knowing. And then the symptoms begin with, fever, cough, shortness of breath, and it depends on each person, might have a different system impacted, but mostly it's the lung that is causing the death. I want to talk a few words about herd immunity, because that's something that is related to the vaccination, which is going to be addressed by Dr. Schooley. But basically, you can see in the upper figure, we have the blue or the purple color of people. Here, they are not vaccinated. And then we have only 2 red people, and they have the infection. And because no one has the immunity, no one has the vaccine, then everybody becomes infected. And that's actually what's been happening, unless people are protecting themselves, staying at home, wearing the mask, and preventing that transmission. Otherwise, it would spread just like that if there wasn't these precautions. If we have some people who are infected, for example, they got the disease or got the immunization, it still is not enough. people are still going to get it. And so the lower one, the yellow one, is that if the majority of people have the vaccine or get the immunity through getting the disease itself, then even if there are new infections, which are the red people, then the transmission will not happen. So you can see there are still some of these blue people who are neither immunized nor had the disease. So they are vulnerable. But look at surrounding them, they're all people who are not going to transmit the disease because they are immunized. So therefore, even if we have new cases, they're not going to transmit. And so we have less of the transmission. And that's really the goal. That's the goal. Now, in epidemiology, we usually say 80%. We need 80% of the population to be protected by vaccination so that the other 20%, even if they don't get vaccination, they are still not going to be transmitting. I've heard others say 70%, others say 90%. That's fine. Within that range, if we can get that goal. So that's why it's really important to get the vaccination. People might say, well, I don't want to get the vaccination. Well, do it for others. Because if you don't vaccinate and somebody else doesn't vaccinate and so on, then the disease can still be transmitted and we are going to be in the same problem and the vaccine will not be effective, basically. I want to show you just a couple of figures before I finish. This is from my April 16th YouTube or presentation that I did. So I did the second one. And look at, this is from San Diego, new cases. And look at the numbers. So we started in March 7th. You can see very small numbers. And then it began to increase, and then it began to go down because there was complete lockdown, complete restriction. Very well and very effective. So things went down and we were almost saying, oh, wow, we're going to control this. I want you to focus right here. So you can see these numbers. This is 150, the largest number on April 2nd, or less than 150. And so it was going down. We were under control. Then, unfortunately, in the second presentation I did on May, sometime late May, you can see that what we saw in the previous slide decreasing, it actually went up. And that was associated with a little bit of easing of the restrictions. And then we had a spread, again, increasing on spread. But look at the numbers. They were still in the 150 range. So that's 159 when the time I did that presentation. Now, unfortunately, look at this. We are in the 4,000. And, this is the other peak that I showed you. It was somewhere here, very small peak. We have reached right here. Now, the good thing, it's going down, right? And that's a good sign. But is it going to go up again? Well, it depends on you. It depends on the community. Depends if people are going to get vaccination, if people are going to still have the social distancing, wear masks. If not, we will. I can assure you, we will have another peak. We will increase. We will have another wave. So the vaccine is, we're lucky, we're fortunate that we have the vaccine. Many countries still do not have access to the vaccine. The vaccine is coming, it's just slow, and maybe Chip can talk a little bit about some of the issues, but we have access to it. People are getting vaccinated, and that's the real deal in terms of controlling this pandemic. So I wanna stop here, and I wanna go back to introduce our guest speaker and our respected distinguished professor of infectious diseases, and he's a physician, Dr. Robert Schooley. He is at UCSD, and he has been a professor for many years here. He was previously in Colorado. He was at Harvard as well. And his expertise has been in HIV and hepatitis C. And he, for many years led the Division of Infectious Diseases at University of California, San Diego. He is now the senior director of international education at UCSD, but more importantly, he has led the effort to address COVID-19 at UCSD as well as nationally and locally. So he kind of led this effort and developed a model of how we can still bring students back, but control it by many testing, and made even machines that one can pay and get the kit to test themselves. And so that has helped to control the infection rates within UCSD campus. So it's only 0.2%, while outside it's something like 5%. So it's much lower. And I've known Chip for many years, and I will kind of give him the floor. I will also act as his translator, because he sometimes switches to the Southern accent, and it's very fast and difficult. So I will slow motion translate that to everyone. No, seriously, he is really a pleasure to have, and I'm glad that he accepted to give us this talk. There was a full coverage in the Union Tribune about him. I encourage you to read it. Very fascinating history. So Chip, I'll leave it up to you to give a kind of overview about the areas you wanna talk about the vaccine, and then I have let's see what are the questions that have come from the Facebook and YouTube that we're streaming to, and then we'll have Imam Taha do the closing remarks.
Thanks so much, Wael. It's a real privilege to be here tonight, and I am looking very much forward to having what I hope will be a very informal session about the vaccine rollout and some of the other challenges we face over the next 6 or 8 months as we watch this epidemic hopefully come to a close after a really horrible 12 months. I'm going to share my screen if I can, and try to make a few comments about the vaccine itself, and about some of the issues related to where we are with the disease. Are we seeing the real screen, or are we seeing the presentation view?
We are seeing the real screen.
Okay,
yeah.
Great.
Yeah.
So, as Dr. Delaney has said, we've had several waves of infection in the United States, and these have been very much mirrored in San Diego. They've reflected the extreme infectivity of this virus. Every time we think that we have it under control and let up, the virus comes raging back. Some of this is our own enthusiasm about getting our lives back to normal, but much of it has been very poor leadership by our political leaders, who have really used this as a political ploy as opposed to a public health crisis that it is. The good news is that after over almost 30 million cases in the United States, and well over 500,000 deaths, we're seeing the epidemic gradually decline over the course of the last 6 or 8 weeks, to the point that we're now almost back to where we were in the fall before this last surge happened. We're now at a state in San Diego where we have only about 9 cases per 100,000 people per week. And that number is important because when we get to 7, some of the restrictions that have been in place in terms of restaurants and meetings will be relaxed, so we can begin to do more than we have been doing. Now, as Dr. Delaney said, this doesn't mean that we should take off our masks and give the virus a chance to rekindle itself, because each time we've let up, it has come back. This just means that we can do more than we've been doing, but we should continue to wear masks and stay away from people who are outside our own families until we see this virus under much better control with the vaccines that are finally coming. Now, the good news is these vaccines are actually among the best vaccines we have. I have to say, I'm very surprised at where we are right now. Reflecting back to where we were a year ago, I would have been really overly optimistic to say that we would have vaccines that are as effective as the ones we have are, and that seem to be as well tolerated and safe as they are. So let's talk about vaccination in general. Why do we do it? We do it because we want to prevent disease. We want to keep people from getting sick. That's the main reason we use vaccines. And we also would like to decrease the amount of virus or other pathogen circulating in our community, so that, as you were hearing from Dr. Delaney, even if you're not vaccinated, you're less likely to come in contact with the virus because there's so much less virus floating around. And this vaccine luckily does both. It both reduces the likelihood of disease. It also decreases the rate of transmission from person to person. Now, we've learned a lot about this virus over the course of the last year. This is essentially a cartoon of the virus that shows that on the surface of this orb, this greasy virus, there are these spikes that are made of protein. And these protein spikes are very important to the virus because this is how the virus chooses the cells to infect. Down below on the bottom is a human cell. And on the surface of this cell, there is a molecule called the ACE2 receptor. Cells in the lungs and in our gastrointestinal tracts are loaded with these receptors. And these two tissue types are the ones the virus is most effective in attacking. And the goal of the vaccines is to be able to have us develop antibodies that will interact with this spike protein and prevent it from being able to effectively interact with its target cells and to decrease its ability to infect both our cells and ourselves. Now, you've been hearing lately about viral variants, and I only will spend a minute about this, but it's important to take them into account. If you go back to I'll step back for just a minute. If you take these vaccine spikes and instead of looking at them from the side, we look at them from the top and look down with the cell below us, you can see them depicted this way. They are made up of 3 identical proteins that come together. This tip right here is where the virus connects with its target. And what has happened over the course of the last year is the virus, like all viruses, gradually mutates when it's allowed to grow in the population. And it looks for better ways to transmit itself around the population. These are opportunists, these viruses are. And if they can find a way to infect more people more rapidly by a genetic change, they will do it. And those new variants will gradually replace the old variants because they're more efficient. And we have right now 2 general types of variants circulating in the population. You've heard about the so-called British strain. They're only called by their geographic name because that's where they were first recognized. It's not because of any other association with the UK. But they have had the British strain primarily has a change right here at the tip of the virus where it interacts with its cell target that allows it to stick more tightly. And instead of touching the cell and falling off and touching the cell and falling off, it touches it, grabs it, and gets in, which makes it much more able to spread in the population. And this virus is gradually replacing the viruses that we've had here in San Diego and that have been present around the world. Now, the good news is that the vaccines that I'll talk about in a few minutes work very well against this virus. The procedures we've used to decrease the transmission in our community also work very well. This virus is just more efficient, which means we have to be particularly careful about wearing masks and not getting into places where other people aren't wearing masks while we're waiting for the vaccinations to pick up. The other general type of vaccine viral variants are these 2, the so-called South African strain and the Brazilian strain. And the key mutation here is this one seen at position 484, because this is a trimer, 3 identical proteins that have come together. It shows up 3 times in the spike. But what this does is it makes the virus less susceptible to the immune response that is generated by exposure to this virus and its predecessors. So we're worried that these new viral variants could come back and even reinfect new people. And as I'll show you in a minute, they also affect the success of the current vaccines to control them. They don't prevent the vaccines from being effective, they just erode their effectiveness a bit. But the reason I'm making this point now is that this virus will continue to mutate, and the faster we get it under control, the less likely it's going to be that this virus will come up with yet another variant that will be harder for us to control. Now, what about the vaccines? As YL said, we now have some very effective vaccines in the United States and around the world. The vaccines that are currently available are highlighted here in red, and they're of two general types. They are vaccines that that use messenger RNA, and I'll describe in a minute what that means, to show your immune system that viral spike protein so that when you see the real virus, you're ready for it. And you can attack it and keep that virus from causing illness. About 2 weeks ago, the Johnson & Johnson vaccine was approved in the US. And this vaccine is one that uses a crippled virus that normally causes bad colds, a crippled cold virus that can't replicate, can't cause disease, to show the immune response this same spike protein, because it has engineered into it the genetic information that causes the virus that carries this vaccine to show your immune response, the same spike protein that these messenger RNA vaccines show. Now, messenger RNA is something that is a native component of life. Messenger RNAs are how our DNA in our cells tell our cells what proteins they should make. So if you go through the life cycle of a cell, this is the whole cell. This is the nucleus of the cell. The nucleus is a bubble inside the cell that contains our genetic information, our DNA. The DNA has a code that tells the cells what proteins to make, and each person's DNA is a little bit different from everybody else's. But the way the DNA in your cells tells your protein machinery what protein to make is that there is an enzyme in the nucleus that copies the DNA and makes messenger RNA. And it's called messenger RNA for a reason. It takes the message from this DNA to your protein machinery and says, I want you to make for me this protein. So every protein in our body has been directed by messenger RNA in any given cell. And what happens is DNA makes messenger RNA. The messenger RNA says, make this protein. Then the messenger RNA over about 12 hours falls apart and gets recycled and goes back to the nucleus to be made into other messages. The messenger RNA vaccines are very similar. The only difference is that the message that's being sent is in the vaccine. Messenger RNA in the vaccine tells your cells to make this spike protein, just this outside of the virus, not the infectious part of the virus, but the outside of the virus. So your immune system can look at it, be ready for it when the real virus comes along. From the standpoint of your cells, it doesn't see this as anything else but just a different instruction that says, make this viral protein. And it works so well because when you get infected with the real virus, you make this same protein. And so your immune response has already seen what it will see if you happen to get exposed to the real virus. This shows what these vaccines will do. This is from the New England Journal of Medicine paper showing in this control trial that included over 30,000 patients, people who got the vaccine in red and people who got a matching placebo in blue, looking at how likely they were to go on and become infected and have symptomatic disease, starting from day 0 when they had their first vaccination. And you may know from listening to the press, the messenger RNA vaccines are given either 3 weeks apart or 4 weeks apart as 2 separate doses. But as soon as 12 days after you've had your first shot of the vaccination series, you begin to have fewer and fewer symptomatic infections. The light circles are infections that are severe enough for you to realize that you've got a fever and you go see the doctor. The dark circle here is a little more severe, but still not severe enough to get you in the hospital. And you can see that people who didn't get the vaccine continue to have infection at the same rate, including both moderate and severe disease. And no one in this study ended up in the hospital or dying from COVID. So even though a few people get mild disease, no one got severe disease and died. The side effects of this vaccine, of these vaccines, the two messenger RNA vaccines, are primarily a sore arm, just like you get with a flu shot, maybe a little more severe. But the sore arm lasts for 2 or 3 days and then goes away. About 5% of people will develop a fever and tiredness. It's more common in younger people because younger people's immune response works a little better. It's more common after the second vaccination because your immune system has already seen this vaccine once, and is revved up and ready to go to respond to it again. So in sum, the messenger RNA vaccines are highly effective and they're very well tolerated, and they're made of a natural part of our human protein machinery. Now, the Johnson & Johnson vaccine, as I mentioned, is made slightly differently. They insert the same DNA profile to make the viral spike protein into a crippled cold virus, and your immune system gets exposed to that. And when you look at the effectiveness of the J&J vaccine, you've heard that it's not as effective as the messenger RNA vaccines. It prevents about 72% of moderate or severe disease. So you will still have a chance of having a fever and having a cold-like symptom, but nobody who got this vaccine ended up in the hospital or died. So it's still very effective at preventing the events we want to most prevent, which is death. It works less well in Latin America and South Africa. And the reason for that is this vaccine, and in fact, the messenger RNA vaccines, work a little bit less well against the Brazilian and South African variants. And because this vaccine was studied at a time those variants were circulating, we began to see the vaccine work not quite as well against moderate or severe disease, but still across the world, it is 85% effective against severe disease. And again, no one who got this vaccine died. Now, where are we in San Diego now in terms of making the vaccine available? Our biggest challenge is availability of vaccine. President Biden has worked really hard to accelerate vaccine production. And both the Pfizer and the Moderna vaccines are being made at a much greater rate than would have happened in the prior administration. And we've recently had an increased number of vaccinations made available with the Johnson & Johnson vaccine. And so in each state, and this will change as I'll discuss in a minute, the availability of vaccine was made first to those who were most likely to die if they got infected. In other words, people who were in nursing homes and who were older than 75. And as those populations got vaccinated, then more vaccine was made available to younger and younger people. We're at a stage right now that anybody in San Diego who is 65 or more can sign up for vaccine, and most people can get it as soon as the vaccines show up from the manufacturers. We are about to go into the next phase in which people who have underlying medical illnesses that are specified in this list by the state of California who are under 65 will also have access to the vaccine. And these are diseases that have been shown in the last year to be more likely to be associated with severe disease or death if you happen to get COVID-19. It includes people who have cancer and are immunocompromised, not everybody with cancer, but particularly people with lymphoma and diseases like that, people who have chronic kidney disease or on dialysis, people who are already on oxygen don't do as well, people with Down syndrome don't do well with this virus, people who have weakened immune response following organ transplants, women who are pregnant are more likely to get sick if they get COVID, which is a reason that these vaccines are made available to them. People with sickle cell disease, people with heart conditions, particularly heart failure, are ones who are more likely to get sick. People who are severely overweight, and people with adult onset diabetes, as well as people who are disabled and would have trouble getting medical care. If you're in any one of these groups, what you can do is self-attest that you are, and as the vaccine availability increases the next week or so, make an appointment and come to one of the vaccine centers, and the vaccines will be made available to you. So I want to stop here so we have time for questions and comments, because I'm sure there are a lot of things that people would like to talk about. But from my perspective as a virologist and an infectious disease person, I think we've been extremely lucky over the course of the last year to have had as much progress in vaccine development as we have. These vaccines, I think, are very safe. They've been very carefully evaluated. None of the steps were skipped to get them approved by the FDA. I was on one of the 3 panels that approved them, and looked very carefully at the data, and all the studies and clinical trials that clinical evaluations we would do with any other vaccine were done. And I've been vaccinated myself, so I feel quite comfortable recommending to my family and friends that these vaccines are ones that you should go and get if you as your group for vaccination becomes available. So let me stop there and turn the podium back over to Wael, and happy to entertain any questions or comments anybody would have. Thanks very much.
Thank you, Chip, for really providing a detailed look at the intricate and the really details of the virus and how the vaccine, because that's always a question. And you already covered several questions that I have collected before our meeting, so I'm not going to address them. But I will ask some of these, and some of them were not questions that came to me for this event, but actually that I have received from YouTube's of people who are who say that they're experts, and I will, no matter how ridiculous they sound, I want to say it because people are actually listening to these wrong advice, and that's why I want to address it with you. But let's start first with the more serious questions, or more meaningful, relevant questions. So one question is, which of the 3 vaccines would you recommend the most that you have mentioned? Clearly, you said the Johnson & Johnson has a little bit less protection, but maybe you can elaborate on the ones that are available.
The Johnson & Johnson vaccine is slightly less effective in terms of preventing moderate disease, but it does prevent severe disease and death just as well as the messenger RNA vaccines do. It has the benefit of being able to be given in a single injection. You don't have to have 2 shots. It can be made in massive amounts, so we can actually we can make it much more rapidly than the Moderna vaccines. And it doesn't require as much care from the factory to the arm. The other 2 vaccines have to be kept at very, very low temperatures, or they become less effective. So this vaccine is one we can get out there right now and really slow down transmission of the disease. We're going to need to come back over the next year or 2 and give booster shots. And it'll be true for people who get the messenger RNA vaccines and the Johnson & Johnson vaccines, to strengthen the immune response and also to be able to deal with these variants. But what I would say right now is, as soon as you are able to have access to the vaccine, what you should do is go get the vaccine that's available to you at the place you're that you're offered the vaccine, and then sit tight, because we're doing studies now to understand better what follow-up steps should be taken after each of the 3 vaccines.
Yes, that's relevant to a question that came just now from the live audience, about saying, well, what is inside the vaccine? Does it have fetal flesh? So I think this is related to some news media controversy just last week about saying that the Johnson & Johnson specifically has a kind of a stem cell or embryo fetal cells, and one of the cardinals of the Catholic Church said, it's not allowed to use it. And I think that question is where it's coming. Does it have fetal flesh? So maybe you can address that.
Well, there's no fetal flesh in any of the vaccines. I think the controversy came up that one of the cell lines used many years ago had come from fetal tissue, but the vaccine itself does not have any fetal flesh in it. And the Pope himself has said that he's endorsed use of these vaccines. This was one of the local archbishops, I think from New Orleans, who made this decision, and the people above in the hierarchy disagree with his comments.
Right. So then it's safe, and there's no kind of problem with this vaccine or the other vaccines. So can I ask a question just for the sake of people who might be outside of the U.S. because thanks to the social media and everything can go elsewhere. Do you have any input about the AstraZeneca and the Sputnik, the V, or the Russian and the Chinese vaccines? Do you have any input on that?
The AstraZeneca vaccine is very similar to the Johnson & Johnson vaccine in terms of how it is made. And I think it's probably about as effective. The challenge with it has been that in doing the trials, they kind of lost their way and tripped over themselves, and it made it complicated to figure out who got what dose of the vaccine at what interval. Oh. And one thing that our regulatory agencies like and demand, in fact, is to know exactly what people got at what time and how to evaluate the data. And while the AstraZeneca vaccine is essentially almost the same as the J&J vaccine, they didn't do the studies as well. And that's why I think they've run into problems with the regulatory agencies. And I would say, from my perspective, that's good because it shows regulatory agencies are paying attention. They're not just green lighting everything through. They are saying, look, we want you to tell us, like we would with any other vaccine, scientifically what you did, who you gave it to, what the results were. This is serious business. And they, in my view, didn't do as good a job of this as the other three vaccine manufacturers did. There are several different Chinese vaccines, and one of them is a nanovirus-based vaccine that's very much like the Johnson & Johnson vaccine. It hasn't been evaluated in the large-scale clinical trials that we've seen here, but again, I would expect it to work about the same based on what I know about it. The Sputnik vaccine we know less about. It was tested only in a relatively small number of people, and then the immune response it generated was measured, but it was never subjected to a trial to see how well it prevented infection. So we know less about it. I don't know of any evidence that it's unsafe, but we don't know as much about how well it protects.
There was a study, Chip, if you came across it in the Lancet about the Russian study, and that I thought was a larger sample, and it shows supposedly 90% protection. Do you have?
That's actually a good point. I'd forgotten about that study, and you're right. That was a study that we haven't seen that from the Chinese vaccines, but that study was helpful, and I apologize for missing that one.
No, so you're okay with that?
Yep, I'm okay with that one.
Okay, great. The other question: do kids under 16 take the vaccine when it's available, and why not? If not.
Well, the original study was done in adults 16 or over, and that's the way we do most medical studies. We don't expose children to things that are experimental until we know more about the safety in adults. And when these clinical trials were finished in adults, the vaccines looked safe enough to move into children. And so the general approach is to start with children who are, for example, 14 to 16 and look to see if they tolerate the vaccine, if they generate the kinds of immune responses we see in adults, then you move progressively down to younger and younger children. That's where we are right now with children. I anticipate that by next fall, we'll know quite a bit about young children. And I also doubt that we're going to see any surprises as these vaccines move into younger populations. I would imagine they'll actually work better because the immune responses in children are better and because children are less likely to get sick. But it's just our cautious approach to exposing children to any risk at all.
Right. So basically, because the studies that were done included those 16 and above, we are applying it. We don't want to apply it because we're following protocol of research and we're confident, that there's no risk. It does, but you're predicting that even those below 16 are not going to have problem, but we need to have the evidence. So that's what differentiates science from non-science. We base everything on very carefully conducted study with panels, independent scientists like you, while people who just read a newspaper or something and then they say, oh, this is this, and then they have thousands of people listening and transmitting this and creating this misinformation. So that's why we are trying to address these, and we would welcome anybody out there who has questions relevant to that. There's a question that is really important, and I think I've asked you actually this before. How long does the vaccination last? And when do we need to get vaccinated again?
That's a great question. And we can only answer that after we've had a large number of people vaccinated for a while and we follow them to see when they start showing evidence of being reinfected. We know from other vaccines that many of them require booster shots every year or two. And this virus is likely to be one of those, in my view. We don't know that yet. But what we'll be doing is watching people who got each of the vaccines and seeing when there's evidence of reinfection. And based on what we see, we'll then come up with a plan to revaccinate. And it may be that we will want to revaccinate people who are older and more at risk for severe disease and people who may not make as vigorous a response the first time around more frequently. I can imagine vaccinating people over 65 every year and people who are younger every other year. But that's the kind of information we'll be generating as we watch this play out.
Great. And relatedly, I know nobody has asked this, but I'm pretty sure it's on the mind of many people is, okay, if I am vaccinated, then can I still transmit the disease? I'm not going to get the disease, but can I transmit it?
Yeah, we know that right after vaccination, in other words, the first 2 weeks after you've been vaccinated, you can be reinfected and you can get sick because that's a period of time before the vaccine has had a chance to develop your immune response. We've looked at our healthcare workers at UC San Diego, and they continue to shed virus for up to a month, and a few of them after a month because they became infected before they got vaccinated or just after they got vaccinated and hadn't had a chance to make an immune response. And after that, the amount of viral shedding decreases substantially. There have been some studies that have gone on for a longer period of time in Israel, among other places, that show that the amount of shedding after vaccination declines steadily, and that in addition to fewer people shedding, the amount of virus they shed is much lower. So you end up in a situation where the ability to spread the virus, which is related to how much virus you have, really goes down markedly. And that's why we are looking forward to a time when we can be a little bit less stringent about some of the other measures that have been so disruptive over the last year.
Right. So that translates into, even if one gets vaccinated, they have to still wear the mask and follow the precautions because they can still potentially, not them infected, get the symptoms, but they can still transmit it to those and if the others who are not vaccinated, for example. And so that's, I think, also what the CDC is saying. Only if you are with somebody else who's also vaccinated and they're not a vulnerable, high-risk group, then you can take off the mask. Is that accurate?
That's exactly right. And we'll have more and more people who are vaccinated, and you can share meals and social events with them as this population increases.
Right.
We'll have less and less virus in the community, and all of us looking forward to a time when we don't have to be quite so stringent with masks. The other reason it's important to wear masks is that when I go to the grocery store, I want to see other people in masks. I don't want to worry about whether that person who's not in a mask got vaccinated or not.
Mhm.
And so until we have vaccines penetrating the whole population, all of us should wear a mask when we're out in public.
Yes. There was a question that came also about suggesting why wouldn't the Uber and Lyft drivers be in the first tier of people who get vaccinated because they are getting in contact with a lot of people?
That's a great question. And, you know, each state has done things somewhat differently. Some states have put policemen in the first line of vaccines, other ones have not. And I haven't looked at all 50 states and territories. Some of them may well have put Uber and Lyft drivers higher up on the list than we did in California. But what I'm anticipating is that we're in a relatively short period of time when we even have to have these lists. And so what I hope we're going to have in the next 6 weeks or so is that everybody can be vaccinated. Then we won't have to figure out who gets vaccinated first. The reason that can be complicated is that if you end up with these very intricate lists about Uber drivers but not Lyft drivers because they have fewer passengers and people drive cabs more often than Uber drivers, what you end up with is something so complicated you can't implement it. And we're trying to get hundreds of millions of people vaccinated. And so we've done the easy stuff, which is if you've got an immune deficit and have cancer, yeah, you should be vaccinated. But it's very hard to know where you prioritize other people. In the meantime, we know from the 3 waves we've controlled before vaccines came along that if people wear masks and socially distance, we can keep the virus at bay. And so that's why I think we should look past trying to figure out how to micromanage the prioritization and just try to get everybody vaccinated, and in the meantime protect yourself and families with some of the measures you've been talking about.
Okay, so now the fun section. I've saved these questions, and don't quote me for it. I'm just really transmitting it to you, and they can be short answers, but some of the things that are circulating heavily and around is that vaccination is high risk for pregnant women.
There's no evidence of that. I mean, the COVID is high risk for pregnant women, and if a woman gets infected and is pregnant, she's more likely to do badly than if she weren't pregnant. And so, again, as in the children situation, the first wave of the studies was done with women who weren't known to be pregnant because we didn't want to have any surprises. There have been no surprises. And now what we're doing is large safety studies in pregnant women. And again, if my wife were pregnant, I would want to have her vaccinated because there have been bad outcomes in pregnant women and in their children with COVID infection.
Okay, and I think you touched on this, but those with immunocompromised conditions, they are to take the vaccine, correct?
Yeah, these vaccines don't use live virus that can be a danger to people who are immunocompromised. Now, one thing I would say is we don't have good data yet about how well people who get these vaccines make antibodies who are immunocompromised.
Mm-hmm.
And that's something we need to be careful about. I have a patient in a friend of mine who has been receiving an antibody to B cells because she has a autoimmune disease, and she got vaccinated, and I told her she should get an antibody test for COVID to see if she made antibodies, because I wouldn't want her thinking she was protected.
Yes.
If the immunodeficiency caused her not to be responsive. And it turned out, we learned on Thursday, that she didn't make antibodies. Mm-hmm. So she's going to have to continue to wear a mask and stay carefully sequestered until we get more people vaccinated, until we get better vaccines for her.
Right, but the vaccine was not a risk to her.
No, I was completely comfortable having her vaccinated. I just wanted to make sure that we knew it worked and made her make antibodies.
Excellent. So there is the thing is you give the vaccine, but you're not sure if the body will react and produce the antibodies. But the vaccine itself is okay to be taken by those, even if they have immunity issues, because
Absolutely.
that's one of the things. Then the other thing that says if you take vaccine, then you become in a low immune situation and you become more vulnerable to the virus.
There's been no evidence of that. I mean, what we've seen is that people who've been vaccinated are extremely unlikely to have severe disease. I mean, the immune response is revved up and ready to go after the virus if you see it. So there's no evidence of it causing your immune response to go to sleep.
Great. Now, has there been any evidence that taking the vaccine causes infertility?
None whatsoever. It's not an issue at all.
Okay. There is a lot of people who believe that taking the vaccine includes a microchip inserted in your system where they know what you do and control you remotely.
I've been vaccinated. I feel totally under my own control. So I don't know of any controls that have been inserted. I worry more about my cell phone than I do about the vaccine.
Okay. The other aspect is that all of this situation of COVID-19 is actually a ploy. The vaccine was created so that companies can make vaccines, and Bill Gates is one of them, so that they can make money. Do you have any comment about that?
No, I mean, this virus is one that is unexpected in terms of coming out of an animal population we don't yet completely understand. We've had this happen 3 times in the last 20 years, and it'll happen again because this class of viruses, coronaviruses, infects other animals around us, including cats and minks and bats, and we live among them. And when the virus jumps species, because we are connected by Boeing and other modes, what in the previous years would have died out and not spread around the world can spread around pretty quickly. So the virus was not created, and from the standpoint of what pharmaceutical companies will make, they make much more money doing other things than this. And I suspect most of them would rather not have been distracted by this with the money they make for other diseases. So I don't see it as a creation to make money for companies.
Okay, well, there are other questions, but they're way far out that I don't want to mention them because otherwise we might get ridiculed by even asking them. But I am conscious of the time, and I really want to respect your time. It's also already 9 evening here in San Diego. And I want to thank you very much, Chip, Dr. Schooley, for a very informative session that will be viewed by many. And I'm going to make sure that anybody, when I get a WhatsApp or any comments about these, I will send them this video, a link to this video, so they can look at it. So I want to, with that, give the floor back to Imam Taha.
Thank you so much. Thank you, Dr. Wael. Thank you, Dr. Schooley. It was really an educational, informative session, a lot of information, correcting and responding to a lot of misconceptions and misinformation, unfortunately, that is spread all over, especially on social media. As I have mentioned a long time ago, at the beginning of COVID, when I did this interview with the media, and I mentioned that we trust our scientists and we believe in science. And this is what we are seeing right now. So it's very important for especially faith-based communities to have this connection with our researchers, with our scientists, in order to benefit from their knowledge as we say, in the matters of faith, we always direct people to go straight to their faith leaders, to their religious leaders, to get the accurate information about their faith from the experts. Also, when it comes to science, it's not me as an imam to speak on behalf of scientists and researchers. We have to bring the experts like you to the table and connect them with the community and let them spread the accurate information about whether the vaccine or the virus or anything that might happen in our society. So on behalf of my community, on behalf of the Islamic Center of San Diego, I would like to thank you again and to thank all the brothers and sisters from within my community or outside the community who joined us tonight, and those who are going to watch this video. Thank you so much for joining us. I pray to Almighty God to bless all of us, to keep us always safe, healthy, and sound, our family members, our loved ones, and everyone on this earth, as we are praying always to Almighty God to take away this pandemic from this earth and to help us to get back to that boring lifestyle that we used to have. Now, we are desperately in need of that. We want to go back to that boring life that we had before. This is when we take, God's blessings and favors for granted. Now we want to get back to what we used to do, and especially embracing our brothers and sisters and getting together as a community and enjoying our friendship. So again, thank you so much. May God bless you all. And should I say see you next time? I don't know, but thank you. Thank you so much.
Thank you.
Good night.
Good night.